Hi, welcome to our discussion on hygrometry. We're trying to figure out how to make measurements of water vapor in our atmosphere. And we already covered the psychrometer. What we're going to do in this video is talk about the errors associated with psychrometers. So there are a number of errors that you can make or can have with psychrometric measurements. And they run the gamut from ventilation and contamination to radiation and inadequate cooling of the wet bulb. So we're going to step through each one and explain what each one of these is. First, the ventilation and time constant. As you know, liquid and glass thermometers have pretty long time constants on the order of about maybe 30 seconds. So that means that you need to be slinging your Sling Psychrometer for a good period of time, more than just 10 minutes or 15 minutes. Whatever type of thermometer you have, it has to be, you have to give it enough time to respond to the changes in temperature that result from the evaporation of water off of the wet bulb. Also, you need to enhance the evaporation of water from the wet bulb, it's best to have some ventilation, in other words, air going by the wet bulb. And it's recommended that you need between 4 to 10 meters per second of air going by the wet bulb. In terms of knots, that would be 8 to 20 knots of wind, believe it or not. So the arm, if you have a Sling Psychrometer, and we'll talk a little bit about Sling Psychrometers towards the end of this video, but Sling Psychrometers don't always have enough oomph to provide the required ventilation. What this means is if you got a decent sized thermometer or psychrometer, you have to sling it between 2 to 5 times per second. And that's pretty hard to do. I can probably get about maybe 2, but 5 is totally out of my league. Other problems or other errors. If heat is conducted down the thermometer stem, in other words, you have some sort of mounting device and it gets conducted to the sensor, then you've got a problem. And usually this is not a problem with glass thermometers, but it is more of a problem with electronic devices conducting heat to the thermometer. Another problem is contamination, whether it be the wick or the water. With water, if you use just straight tap water, it'll have all sorts of chemicals in it. Of course, chlorine is typically put into drinking water, or tap water. So you need to have water that is pure, and typically we use distilled water. The other thing is the wick. Wicks also may have, if you use just regular fabric, then it may be treated. If you put it in the washer, it'll have fabric softener on it. So these are things you have to consider when you're designing a psychrometer. So of course, the water needs to be distilled and deionized. And the wick needs to be a specific wick that's designed for psychrometers. In other words, it can't be treated with any chemicals. Has to be a pure fabric. Also, another problem is making sure that your wick is wet enough, get it good and saturated. If you don't saturate the wick, get enough water on the wet bulb, then the temperature may end up being the same as the wet bulb temperature. In other words, you won't see a drop in the wet bulb temperature. And if that's the case, it's telling you're at your saturation. And if you don't see fog and you're at saturation, then probably you've got a problem. So make sure your wick is fully wet. Another problem is if your wet bulb temperature is greater than your temperature of the dry bulb. That can't happen. If that happens, that means there's more water vapor in the air than there really should be. You're at a super saturated condition. So that only happens in the bottom parts of cumulus clouds. So you need to check your thermometers because one of those thermometers is not reading properly. Other problems, if you're slinging your Sling Psychrometer or any psychrometer and you don't give the wet bulb enough time to reach its final temperature, that means the wet bulb temperature is going to be higher. That will cause the problem of making the air assumes, or it appears as if the air has more water vapor than it really does. You think of it this way, if you stop halfway in your measurement of the wet bulb, then the wet bulb is going to be higher, which means that the air hasn't evaporated, or the water hasn't evaporated into the air off of the wick. So it thinks that there's more water vapor in the air than there really is. So you tend to overestimate the amount of water vapor in the air if you never reach your true wet bulb temperature, if you stop halfway at a warmer temperature. Usually this is not a problem if you got good ventilation, but you have to give the wet bulb time to reach its final temperature. Other problems, the thermometer, both the dry bulb and the wet bulb need to be shielded. Remember that radiation is a big cause for errors with thermometers. So it needs to be shielded either in the shade or some sort of device that's not allowing solar radiation or infrared radiation for that matter to reach the thermometer's sensors themselves. There are a bunch of different types of psychrometers. Most people have used a Sling Psychrometer. We'll talk about that. But there's also aspirated and naturally ventilated type thermometers, as well as the Assman type psychrometer. Sling psychrometers are ones where you have a wet bulb and a dry bulb on a mount, and that mount has some sort of pivot at the end, a handle with a pivot, or it could be a chain for that matter also. And what you do is you move it around in a circular motion so that you are ventilating both the dry bulb and the wet bulb together. And they're whirled around. Remember, they need to be moving at about 2 revolutions per per second. 2 revolutions per second at a minimum. There are also aspirated or ventilated psychrometers. These are ones that are not being slung around. They may be in an instrument shelter or something like that. And the wet bulb has a source of water. In other words, maybe just the tip of the wet bulb, the very bottom of the wet bulb is the wick is in the water, absorbing water. But then as it goes up the wick, it evaporates. And what they do is they have a fan, typically an electric fan, a little switch that you can turn on that blows air by the wet bulb wick so that it's constantly evaporating. And that gives you a reading. And they say typically about 3 minutes you'll get a wet bulb reading. Another type of psychrometer that is aspirated, naturally aspirated, that's one in which, as you can see here in the picture, the wick is once again dipped into some water. But in this case, you don't have a fan blowing over it, so you're looking for natural aspiration. In other words, the wind, if there's any wind, to blow over that wick to evaporate it. So there's no artificial means used for aspiration or for ventilation. And as a result, it takes longer, much longer, to reach the wet bulb temperature. If the water in that bulb and in the wick is the same temperature as room temperature, it can take up to 15 minutes. But if it's colder or warmer, if it's a different temperature, that water in that bowl, in that little bottle, then it can take up to perhaps maybe 30 minutes for it to actually record its true wet bulb temperature. And then finally, there's the Assman Psychrometer. This is a special type of psychrometer developed by Assman. It has 2 mercury thermometers. One's a wet bulb, one's a dry bulb. So it's kind of similar to a Sling Psychrometer. They're side by side, except you don't sling this. Notice that there's kind of a key at the very top of this. That key is, in fact, a key that winds a spring, and the spring drives a fan. So this is constantly sucking air past the dry bulb and the wet bulb. You can see that they're enclosed in kind of a metal encasing that's actually either chromium or nickel-plated polished metal frame. And what that does, it screens the bulbs from solar radiation, so you don't get radiation error. So the air comes up through the bottom and it goes out through the top through the fan. And it's open on the side so you can actually look at the temperature of the wet bulb and also the dry bulb. So those are the different types of psychrometers and also the errors associated with those psychrometers.